81. What are the concentrations of Ag+, Cn- and AgCN2- in a saturated solution of AgCN? Okay, so first things first, they didn't give us any values here, right? All they told us was that we're at a saturated solution of silver cyanide. Now, when we are dealing with saturated solutions, that means that there's like no common ions that are affecting this solution. And if we're saturated, we are definitely using the Ksp value of that compound. And we've been doing tons of Ksp problems, right? You always have to write out the balanced equation. So the first thing is I'm just going to write out the dissociation of AgCN. So I have AgCN, and since it has a Ksp solubility product, it always starts as a solid. And double arrow indicates that we're dealing with equilibrium, K values. And they did tell us the charges of the ions, so thank you for that. Ag plus Cn-, just make sure that you are balanced, but we're balanced here. I have two charges, so aqueous all around for the products. And remember, those are a solid. What I'm going to do is I'm just going to take this Ksp value and just move it over here. Okay, and then maybe I will get rid of this. So that's the first part done. So I'll just say saturated solution, we're using Ksp. Okay, so that was the key for that. Okay, however, they're telling us that we also have another compound that's being formed, and that's the complex ion, AgCN2. I know that this is a compound because I have a metal coming together with a polyatomic, and they share a charge. So when you have a metal and a polyatomic coming together with a charge, it's a complex ion. However, when you have a metal coming together with a polyatomic and there's no charge in the upper right-hand corner, that's just a regular ionic compound. So I had to go in the back of the textbook to find out what that Kf is. And I'll write this down here. So for complex ions, which is what that AgCN2 is, for complex ions, we have Kf values. For regular insoluble ionic compounds, we have Ksps. So that's the difference here. So let's write out the Kf equation. Keep in mind that Kf, the F stands for formation. So you are forming your complex ion. So if you're forming this actually has to go on the product side. You're forming it from your ions, right? The Ag plus and the Cn-. So in this case, you have Ag plus coming in with Cn-, and we got, let's see here, Ag, Cn2 minus, and that's also aqueous, right? Just make sure that this one's balanced. You do have two cyanides, so I do have to put a 2 in front of here. Okay. And if I can, I'm just going to take this Kf value and place it over here. And then I will erase for this compound. Let's move this on up. And now let's work with it. Okay. So now let's write out the two different K expressions for both equations. So I'll first start with the top one. So in this case, we're going to say Ksp equals, keep in mind that the Ksp, since this is a solid, the AgCN, we don't care about this component. So the Ksp would be basically equal to the concentration of those two products. So in this case, we have Ag plus times Cn minus. Now, since we don't know what the Ag plus and the Cn minus are for now, I'm just going to hold on for a little bit. And in this case, I'm just going to fill in the values. So the Ksp would be 1.2 times 10 to the negative 16th, and this equals the concentration of those two ions. So I'm just going to copy and paste this. Okay. Now I'm going to do it for the bottom one. Now it seems for this one we have all aqueous, so I have to include all these ions in my formula. So Kf equals, this one seems to have a denominator. So I have one numerator and I have two denominators because of the two reactants. So it seems like I have AgCN2 minus on the top divided by the Ag plus times the Cn minus. Keep in mind that for this one, there is a 2 here. So I have to take that Cn minus and just raise it to the second. Now let's just fill in the value. So the Kf value was 1.0 times 10 to the 21st. And this is going to equal, I don't know yet, so I'm just going to copy and paste this. Okay, so let me just move this a little bit up and this a little bit up, because what we're going to do now is we're going to use these two pieces of information to substitute. Now, as you can see here, they both have Ag plus and Cn minus. So technically, I could sub one out for the other. It really does not matter here. So what I'm going to do is I'm just going to solve for, I guess we'll solve for the Cn minus here. Doesn't really matter. But for me, let's just solve for Cn minus. So if I do that, I'm just going to say that I don't want the Ag plus on this side anymore. I'm just going to divide by the Ag plus. So Ag plus and Ag plus. That will cancel. And now for this equation, it just says that the Cn minus equals 1.2 times 10 to the negative 16th divided by that Ag plus. Now what I'm going to do now is, since I have what my Cn minus equals, I'm just going to come over to this equation and I'm going to simplify it and plug in what the Cn minus equals. So the Cn minus, just like we said, the Cn minus just equals 1.2 times 10 to the negative 16th divided by that Ag plus. Okay, so let's do the math over here. So now I have 1.0 times 10 to the 21st, and this is going to equal, the numerator didn't change, so that's the AgCN2 minus. The Ag doesn't change. The only thing that's changing is now I'm just inserting this in for the Cn minus. So now I'm going to say that this whole thing is 1.2 times 10 to the negative 16th divided by Ag plus, and that is squared. So this whole thing is now squared because we have to keep that in there. Okay, so let's just simplify this out, right? Basically, if you have a value squared, that means you just have two of them. So technically, I just have to multiply. Actually, what I'm going to do is I'm just going to delete that, and I'm going to say this is plus 1, right? So basically, I'm just going to take this value and square it, and this value and square it. If you have a denominator, the top and the bottom have to be squared. So let's do this first. 1.2 times 10 to the negative 16th squared. 1.2 times 10 to the negative 16th, and that's squared. So I get 1.44. I'm just going to erase this. This is 1.44 times 10 to the negative 32. And this is all over now Ag squared. But if we just extend this line and I bring this over here, now I can simplify. I have one Ag on the top and two Ags on the bottom. So in essence, this one goes bye-bye. And now I just have an Ag plus on the bottom. So if I can, this one is just kind of like a crazy substitution one. I'm just going to say 1.0 times 10 to the 21st equals, we still have the Ag CN2 minus on the top, and now it's just 1.44 times 10 to the negative 32 divided by the Ag plus. Okay. Well, now we can cross multiply, or keep in mind that this is basically keep, change, change, right? If you're dividing by a fraction, you multiply by the reciprocal. So if you need to, pause the video. I'm just going to get rid of, I guess, these two things, because we still have some math to do. So just pause the video if you need to write anything down. But there we go. And now I'm just going to move this over just so that I have more room. And now I'm just going to do keep, change, flip. So it now becomes 1.0 times 10 to the 21st equals, that concentration is the same, AgCN2 minus, times the flip of this fraction. So now the Ag plus is now on the top, and the number is now on the bottom, 1.44 times 10 to the negative 32. Okay. Now keep in mind, if you have two things that are being multiplied by each other on one side, you just push them together. So now this whole division sign goes under with that number. And then you have your two variables up top here. So now I'm just going to cross multiply. So we're getting there. Now this equals Ag CN2 minus times Ag plus. So I have 1 times 10 to the 21st times 1.44 times 10 to the negative 32. Just want to make sure I put in all the right numbers. There we go. And I get 1.44 times 10 to the negative 11th. Okay. Now, in order to make this work, we have to assume, right? We don't have x values here. So I'm going to have to assume something. And this is what it is. Keep in mind that if we go back to this equation, the one that has these two components in it, this Kf value is very large, which means that at equilibrium, chances are you're going to have mostly the product, the common ion, the AgCN2 minus. But in order to form that, keep in mind that you had to have had the starting Ag plus. Remember, we only had AgCN, so we know that we had initial Ag plus to make that AgCN2 minus. So the idea here is that whatever you had of this, assume that all of it is going to be produced into your final, complex ion. So use those ratios. It was a 1 to 1. So if I'm going to label this as X, I'm going to form the same amount, X. So now I'm just going to say, okay, this is X and this is X. Because I'm going to assume that whatever I had in the beginning is going to get transferred into that product. And now the math makes it a little bit easier. So we have 1.44 times 10 to the negative 11th equals X times X. And X times X is just X squared. So just take that square root. So X equals the square root of that number. And I get 3.79 times 10 to the negative 6th. And we already have 2 out of the 3 answers. We did say that the Ag plus is that number because we labeled it as X. So 3.79 times 10 to the negative 6 molarity. We also know that the AgCN2 minus is also that number, 3.79 times 10 to the negative 6 molarity. Now, what is that Cn minus concentration? Well, remember when we made this Ksp equation, right? And then we substituted for what Cn minus was. Cn minus, I'm just going to repeat it up here. Or actually, I think I have more room on the other side. So I'm going over here. Remember when we wrote down that Cn minus equaled 1.2 times 10 to the negative 16th. That was the KSP. And we divided it by the Ag plus concentration. And now we know what that concentration is. The concentration for Ag is 3.79 times 10 to the negative 6th. So, how are we going to find out the CN minus concentration? Yeah, we just take those two values, right? 1.2 times 10 to the negative 16th divided by 3.79 times 10 to the negative 6th. And I get 3.17 times 10 to the negative 11th. And that's molarity. So that's what the CN minus concentration is. 3.17 times 10 to the negative 11th. And we finally have our 3 concentrations. So this one was nuts, mainly because we had to substitute and then use that value back for solving for the CN minus. But we got it. I really hope this helped you out. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. Thank you. And I will be talking to you in future lessons. Okay. Have a great day. Bye-bye.